Okay, so this is graphing lines using technology. Okay, so using decimals. So we're learning to use decimals to make a scatter plot, learning to use decimals to find the line of best fit, learning to then use your line of best fit to make predictions, and learning what linear regression is. Okay? So, here's our first example. Joe measures the growth of a seedling. Graph the data using technology. So, we're going to now enter that data into Desmos, and I'm going to show you how to do it. Okay? So, is everybody on your Desmos screen? Everybody? Okay? Because you're going to have to do one of these on your own and show me as your mark for the day. Okay? 2 of them, actually. All right, so it says we're going to add a table. So you go to add, see the add item here, and you add a table. Okay? And then the first thing we're going to put in is 1 for X, and then 4 for Y. Okay? Then you go down to the next level of the table, 3 for X, 12 for Y. Go down to the next level of the table, 5 for X, 22 for Y. 7 with 36, and 9 for 45, 9 and 45. So now you've entered your data, okay? The next thing we want to do is see all of that data plotted on our grid. So to do that, see this wrench over here? The wrench, it's on the right side of your screen. It says graph settings. When you click on it, click on the wrench, and you want to change the x-axis so that it doesn't start in the negatives. So we want it to start at 0. And how high do we want it to go? Maybe like 15. And then the y-axis, we don't want to start in the negatives, so let's start at 0. And we want it to go as high up as 45, so I'll put like 50. And now if you click anywhere else on your screen, once you put those, so 0 to 15, 0 to 50, click off, you should see all of your data there. Does everyone see all of their data now? On the screen. Okay? Now does it, based on what we did in the first part, does it look like a positive or negative trend? Positive, okay. And what are we talking about here? We're talking about growth of a seedling, okay. So as the days increase, the height of the seedling increases, okay. So A says describe the relationship. So we're going to go back and describe the relationship. Remember, we say always start off with as whatever the independent variable is, which is time. As time increases, the height of the seedling increases. There's our description, the height of the seedling. Increases, and we talked about it being a positive correlation. Positive correlation. Now if you turn over the page, you see how we're going to get the computer to figure out the equation of the line of best fit for us, which is super cool. Okay? We're going to use the computer to figure out the line of best fit for us. So, and it's called linear regression. It's the process of the computer figuring out the line of best fit, the perfect line of best fit. So we don't have to guess, we don't have to try it with our ruler. The computer will generate the perfect one. Okay? All right, so go back to your computer screen, and below the table, pick another box there. And then bring up your graphing calculator so you can see the buttons. And if you look at what we have to type in here, it says y1. So you're going to hit y and then 1. y1. Can everyone figure out y1 there? Now, instead of an equal sign, there's this little curly thing. Does anyone know what that means? Not equals. This means approximately equals. And that's the hint to the computer that they're going to do linear regression. Okay? You're not just typing a line and you're getting them to find it. So to get that approximately, you have to go to the ABC part. And then you see it in the bottom here. This is the approximate sign. Approximately equals M. It should be M. I don't know why it says A there. MX1 X MX1 plus B. So you've just put in the equation of a line there. And then once you've done that, get rid of your graphing calculator so you can see what it gives you. Okay, so it draws in the line of best fit for you. And this box here tells you its equation. So how does it tell you its equation? Well, it tells you what the slope is. So the slope is 5.3. And it tells you what the y-intercept is, minus 2.7. Okay? So the equation of this line they drew on is y equals 5.3x minus 2.7. Okay? So down here where it says what m and b are, that gives you the equation of the line. This thing called r squared here is called the correlation coefficient. 1 is the strongest possible correlation. That means they're 100% correlated. So how strong is our correlation? 0.9919, really strong. This is a strong positive correlation. Okay? Highest you can get is 1, and we've got 0.9919. Okay? All right, so now we have to go and copy that back. So 5.3x minus 2.7. So go to your note now. Y is approximately equal to 5.3x minus 2.7. That's our equation of the line of best fit. Now it says use trace to find the height of the seedling after 4 days. So go back to your Desmos. Trace. Where is trace? Is it here? No. Is it here? No.
No.
I forget where trace is. Trace. Oh! Okay. So we're trying to find the height of the seedling after 4 days. So what I would do, can't do that, is, so I would go up, I'd figure out where 4 is. So here's 4. And then click right there until it says 4. 4, do you see how that says 4 and 18.5? If you click right at 4. Everybody see that? 4 and 18.5.
They're going to the bathroom after kids.
Whoa, I was supposed to go before, right?
Whoa, what you did?
Whoa.
No, you've already been out once today, Paul. Can you take your hood down too, please?
Can I go to this one?
Well, make sure you know how to do one of these because that's you have to be able to do one to get your mark for this. Okay, so 4 and 18.5. So then you go back over here. Where are we at? Here. 4. So the graph told us 4, 18.5, which this is the day, and this is the height. And then if we look here, it says that our time was in days and our height was in millimeters. So day and millimeters. So using the graph, the height would be 18.5 millimeters. Okay. So it says change your window, then find the height of the seedling after 10 days. We'll see if we need to change our window. I think we went to 15, so we're okay. But you can zoom in and out. Okay. So back here after 10 days. Okay, so then we're going to go over to 10. Where do we hit the line? 10 and 50.3. 10 and 50.3. You can see right there. Okay, so then we go back to here. Our order here was 10 and 50.3. This is days. And this is millimeters. Thank you. My backup pair, but I think so. Glad they're not broken. Okay, so then we're going to say the seedling is 50.3 millimeters after 10 days. Nice. So see how the computer is doing all that work for us. It found the line of best fit instead of us having to find it. It's predicting, it's helping us make the predictions. Okay, so that's our first question. Here's our second one. It's got a lot bigger table to put in, so you want to erase everything on decimals from your first one, and now we're going to start doing this next one together. And then there's 2 for you to do yourselves after we've done this one. And that's today. Okay, so I've got to get, so the easiest thing for me to probably do is just to go out of it and then go back in. So decimals graphing calculator. Interesting. Okay, so we're there. So who remembers what's the first thing we do? Yep. Get the table. So you go to add table. Okay? And then we're going to start. So our first column is going to be our x. So height, we're going to go 150. And then the mass beside it is 51. Go to our next row, 151. And then 56 goes with that. And some people like checking them off once you're done so you don't get out of whack or miss a point, okay? 152 and 54. 154 and 58, 156 and 56, 158 and 62, 160 and 91, 161 and 65, 64 and 66. Yeah. One 66 and 71, 170 and 74, 172 and 74. Okay, so once you have your table, put your hand up so I can see. Okay, we're still waiting for a couple people. Josh, you got your table entered? Paul, you got your table entered?
What?
Jacob, do you have your table entered? Got your table entered? Yep. Okay.
Good idea.
Who remembers what you do after you've got your table in? Not yet. You got to change your window so you can see all the data points. So you go to the reg. And what's the smallest x value we have? No, look at our list. 150. Right there, smallest x value we have, 150. So maybe I'll do like, I don't know, 140. And what's the biggest x value we have? Yep, 172. Biggest x, 172, so I'll go up to 180. What's the smallest y value we have? 51, so I'll start at 50. And what's the biggest y value we have? 74, so I'll go to 75. And now when you click off of that, you can see your whole scatter plot. Yep. Oh, the biggest one's 91, thank you. Go back to your window then, you just go back here, and then we'll add up 100 here. Nice, Maddie, good catch. Now, I'm really glad you caught that because does that data point make sense? Does it follow the trend of the rest of the data? No, it's like way off of whack, right? This one's called an outlier. An outlier, because it's all out alone, okay? Perfect, that's an outlier, okay? It doesn't follow the rest of the data. Now we're gonna do our line of best fit, so click below your table. So you add in another spot to put an equation, and then you're gonna type in with your graphing calculator, y1, and then you need that approximately, which is in your ABC, is approximately equal to mx1 plus b. And then once you've typed that in, it tells you the equation of the line. Okay, so there's a couple of things I want to show you here. So it's telling you right now the slope of the line is 1.05 and the b value is negative 103.243. But what's our correlation coefficient? R squared. 1 is the best you can get. This one's not even 0.5. What do you think's affecting it? these ones all look pretty solid. That one is affecting it big time. So what often happens in a data set is you take out any outliers and then you redo it. So let's do that. So we're just going to take out the outlier, which was the 91 one here. So I'm going to get rid of 160 and 91. Get rid of it. And now I'm going to do this again. Oops. Guess I have to type it in again. Is approximately mx1 plus b. Why isn't it working? Maybe I have to delete that. Yeah, okay. There we go. All right, so if I delete that, and now I come down here without the outlier, what is my correlation coefficient now? 0.958, very highly correlated, okay? And my slope and my y-intercept are a little bit different, okay? But it's very highly correlated with that. Outlier in. Okay, so let's look at what questions they asked us. We did that. Okay, so let's write in our equation of our line was y1 is approximately 1.05x minus 104.835. So that's the answer to B. This should be an X one, I guess. And we'll retype it here. Where am I going? Here. Y1 is approximately, what was the number? 1.05. X1 plus minus 104.835. Okay, describe the correlation and the relationship. So if you include the outlier, it would be a weak positive correlation. Remember, because it was only a 0.4 something?
Could I go get a drink, please?
Not right now. And if you exclude the outlier, it is a strong positive correlation. Okay, so this one was r squared is approximately 0.45, and this one was r squared is approximately 0.9. Okay, so big difference between including the outlier and not including the outlier.
When can I go get a drink?
When the lesson's done?
How long is one? Really? Stop talking.
Okay, so it'll take a little while to copy that down, and we have to use the data to predict, we're only predicting the height of a student with a mass of 80 kilograms. So we go to our graph for that. So 80 kilograms is the mass, and mass is the y value. So we're going to go across, we're going to actually click on our line, but we're going to go across, right? Until we hit the line, and then see what that point is when we use our screen. So if I click right there, oops. I think I have to erase right there. Let me just see it. Okay, so we go across from 80. And then we're going to hit our screen like right here. That's the point. We want to get just to exactly 80 if we can. I don't know if your hand's as steady as mine or steadier. That looks like as good as I can get. Try to go a little bit lower. No. I got closer than that before. There, that's pretty good. So 175.95 and 80. So 175.95 and 80. So again, the first column, if you go back up to the question, this is the X, this is the Y. Okay, so the mass is in kilograms, the height's in centimeters. Oh no, I'm backwards here. Centimeters, kilograms. So therefore, I predict, or the graph predicts, the height of a student with a mass of 80 kilograms. Guys, stop, please. Okay, so that's how you use Desmos to predict. Just click on with your finger that point, write down the point, interpret the point. Remember, this is always the X comes first and the Y comes second in the table and in the point. Paul, can you just stop, please? Okay, but just stop talking. Please. Predict the mass of a student who is 2 meters tall. Okay? Interesting. What's our height measured in? Centimeters. So first of all, I have to figure out what's 2 meters in centimeters. Does anyone know the relationship? Yeah. 200. Good. So there's 100 centimeters in a meter. 100 centimeters is 1 meter. So 2 meters would be 200 centimeters. Good. Okay. So now I'm going back to my graph. And I want to find 200 centimeters. And notice I don't have 200 in, so I have to change my window. So I have to change my window, so I go up to the wrench. And I've got to change this from 180, and let's make it 220. Click on the screen here. And then same thing with my y-axis. I have to go up farther than 100. So I'll go up to 150. Paul, I asked you to stop talking. So 2 meters is 200 centimeters. I go up to my line, click on it. Again, there's 200, 105.172. 200 and 105.172. Again, this is the X and this is the Y, and X was centimeters and Y was kilograms. Predicts the mass of a student who is 2 meters tall. So I predict that the person would be approximately 105.72 kilograms in weight. lesson. Now you guys do 2 of them on your own. Once you've done one, I'll check it off. Once you've done the second one, I'll check it off. I've got answers I can compare with.
Do we get to do them?
Yeah, you're doing that. And the tutors, no, you don't have to do a annotated lesson for them, but you can do them to compare with your partners if you want to help them.